Why, hello there. Today we have the hard integral from dailyintegral.com from June 1st, 2026. So let's just get right into it. We have the integral going from 0 to 3 of the mean function of sine pi over 2 minus pi by 6 times the floor of x and cosine pi by 6 plus pi by 6 times floor of x with respect to x. Okay, so pretty much the mean function of x and y is just equal to x plus y over 2. So that means we can rewrite the integral as the integral from 0 to 3 of sine of pi by 2 minus pi by 6 times the floor of x minus plus cosine of pi by 6 plus pi by 6 floor of x, all of this over 2 times dx. And let me just rewrite the fraction bar. Perfect. Okay, now we can take out a 1/2 and we get the integral going from 0 to 3 of, so sine of pi over 2 minus pi over 6 can be rewritten as cosine of just pi over 6 times floor of x plus cosine of pi by 6 plus pi by 6 floor of x dx. Okay. Now we have a nice addition formula where you have cosine of a plus cosine of, beta plus alpha is equal to 2 cosine of alpha plus beta over 2 times cosine alpha minus beta over 2. Now these 2's over here will cancel out, and then we get the integral going from 0 to 3 of cosine of pi by 6 plus pi by 6 floor of x times 2. So that is just, we get 2 pi by 6, which I'm going to keep it like that, and then plus pi by 6, all of that over 2, times cosine of pi by 6 floor of x minus pi by 6 floor x plus, or minus, pi by 6, all that over 2. And these two terms would cancel out, and then we end up with just a pi over 6 over 2, which is just pi over 12, or it'll be negative, but since cosine is an even function, it doesn't matter, and then with respect to x. And then we finally get the integral. We'll first take out the pi over 12, or cosine pi over 12. We get the integral going from 0 to 3 of cosine of 2 pi floor x plus pi over 12 dx. And now we have the beautiful cosine of a plus b is equal to cosine a cosine b minus sine a sine b formula. And now we have, so for our integral we will have cosine pi by 12 of the integral from 0 to 3 of cosine of pi by 6 floor of x times cosine of pi by 12. Now I'm going to do the linearity of integral operators. I'm just going to separate this, and then we're going to have another cosine of pi by 12 times the integral from 0 to 3 of sine pi by 6 floor of x times sine of pi over 12. Yes. Okay, and then dx. Now we can evaluate these integrals, which I'm going to rewrite them real quick. I'm going to have, so we'll have I is equal to the cosine squared of pi by 12 times the integral from 0 to 3 of cosine pi by 6 floor of x dx minus cosine pi by 12 sine pi by 12 times the integral from 0 to 3 of sine pi by 6 times 4 of x dx. Okay, so now we just have to integrate floor functions, which is not too bad. Actually, the first thing I'm going to do before I do any of that is I'm going to simplify cosine of squared of pi over 12, so that would just be 1/2 plus root 3 over 4 times the integral. We'll just call this I1. Actually, I'm going to color code them. So we'll have I1 up. We'll have I1 in blue. We're going to have minus, or we're just going to include this all into I1. So, yeah. And then cosine of pi by 12 times sine of pi by 12 is just sine of, or 1/2 sine of pi by 6, which sine of pi over 6 is just 1/2 times 1/2 is just 1/4. So we get 1/4 over there. So we get, whoops. So we're going to have cosine squared of pi by 12 is equal to 1/2 plus root 3 over 4, and sine of pi by 12. Cosine pi by 12 is just equal to 1/4. And we'll add the negative sign just so we are aware. Okay, and now we'll have the integral I1 and then the integral I2. So let's evaluate I1. So we'll have the integral I1 is equal to the integral of, we'll just let this equal to a constant for now. We'll just make it equal to a constant. What's a fun one to write? We'll just put k. No, I'm going to use k later. Let's just put a constant of t for tangent. Yeah. Okay, so t times the integral of 0 to 3 of cosine of pi by 6 times the floor of x dx. Now for the floor function, that implies x is between k and k plus 1, and whenever x is in between them, the floor of x is always equal to k. So now we can rewrite our integral as I1 is equal to the integral of the sum, well, I could write t on the outside, the sum of k equals 0, and our bounds are 0 and 3, so 0 to 3 of the integral from k to k plus 1 of cosine of pi by 6 times k dx. And now we can just simplify this to the sum, which is just equal to, I'm going to rewrite this 1/2 plus, or what was it, minus, not plus, 3/4 times the integral from 0 to 1 of cosine of 0 is just 1, so we're just going to have integral of dx plus the integral from 2 to, oh, sorry, not 2 to 3, 1 to 2 of cosine of pi by 6, which is just equal to root 3 over 2 dx, and then plus the integral from 2 to 3 of cosine of 2 times pi by 6, which is pi over 3, which is just equal to 1/2 dx. Now we're going to have, this is just equal to 1, and then we're going to have a 3/2 x going from 1 to 2, and then plus a 1/2 x from 3 to 2, and then times our constant over here, and we're going to end up with a I sub 1 is equal to 9 plus 5 root 3 over 8. Okay, wonderful. Now we can get started on I sub 2, which is just the same thing, but we're going to be doing, it's the sum over k from 0 to 3 of the integral from 0, sorry, not 0, k plus k to k plus 1 of sine pi by 6 over k dx, which that is just equal to negative 1 over 4. I forgot the constant over here. We'll write it there. Times the integrals of 0 to 1 times 0, or sine of 0 is just 0, so we'll get 0 dx plus the integral of 1 to 2 of sine pi by 6 k, and then that's dx, and then plus the integral from 2 to 3 sine of 2 pi by 6, which is just pi over 3 dx. And then same thing, well, this goes to 0, obviously. This integral evaluates to 1/4 times 1/2 x from 1 to 2 plus root 3 over 2x from 2 to 3. Yes. And then you'll end up with the integral I sub 2 is equal to 1/4, or negative 1/4, that is 1 plus root 3 over 2, which is just equal to negative 1 plus root 3 over 8. And now if you recall, the integral is equal to I1 plus I2, which therefore implies I is equal to 9 plus 5 root 3 over 8, which actually I'm going to hold off on that. We're going to 9 plus 5 root 3 minus 1 minus root 3. Sorry, I just realized this would be the negative of the fraction. So we'd have a negative sign over here, which you distribute that, and then you get over 8, which is just equal to 8 plus 4 root 3 over 8, which is just equal to 1 plus square root of 3 over 4. Or you could rewrite that as square root of 3 over 2. My answer I put in the integral was this. So overall, we get I as the integral going from 0 to 3 of the mean of sine of pi over 2 minus pi by 6 for x, and cosine of pi by 6 plus pi by 6 times floor of x dx is equal to simply 1 plus square root of 3 over 2. And now, yep, just a little verification. Yep, that is correct. This was a fun integral. It wasn't really that hard. It was pretty easy. For the hard integral, I expected a little bit harder, but surprisingly, it was pretty easy to do. So yeah, that's the integral, and hope you had as much fun as I did, because this was a fun integral to solve. Floor functions are always interesting, especially when it's a finite floor. It's always nice. Anyway, catch you guys on the next one.